Let's talk about heterolytic fission, or as I like to call it, the unequal and the unfair working of electrons. Now, the word itself, hetero, means different, and the word lytic indicates splicing. And in our case, we are splicing a bond, breaking a bond. Let's imagine an example. So let's say we have two atoms in front of us, atom A, atom B, both are bonded together. Now, since we have a single bond, we have two electrons that are being shared right now. So two electrons are being shared right now. And let me make those electrons as well. 1 second. So these electrons are involved in the bond, right? Now what's going to happen in heterolytic fission is that when this bond breaks, the atom that is way more electronegative than the other, so let's imagine that B is way more electronegative, than atom A, it's going to hog all the electrons, which makes sense because it's probably going to be like, all right, I have a higher tendency to gain electrons. So when this bond breaks, I'll probably keep all the electrons to myself. And that's exactly what happens. So if we make the products that we're going to have, and if we break the bond right there, the bond is broken, B gets to have both the electrons. There we go. And this is our, by the way, anion. And we'll have our cation. So usually in heterolytic fission, the products are ionic in nature, positively charged, negatively charged. हेटेरोलिटिक फिशन आपको वहाँ पे देखने को मिलेगी उन एटम्स के दरम्यान में that have a higher electronegativity difference. ठीक है, चलें. Let's do two examples to better understand heterolytic and homolytic fission. Starting with an example of heterolytic fission. They have already mentioned that there is going to be heterolytic fission of the C of this bond right here. A bromine is way more electronegative than carbon. It's probably going to keep both the electrons that are involved in the bond. Right? So let's make our product. We'll probably have bromine. Let's make that. And it has hogged both the electrons. Wait, let me draw that in a different color. There we go. It has hogged all the electrons. And we'll be left with a positive cation. Let me draw that as well. So we have CH3, CH. There we go, with a positive charge on. See? So we have two species, both of them charged, an anion and a cation. So this was an example of heterolytic fission. Now let's move on to an example of homolytic fission between carbon-to-carbon bond in C2H6. This is the bond that we're breaking. Let me highlight this. There we go. Again, same story. Two electrons are being shared here. So when this bond breaks, both electrons are going to be divided equally. So what are we going to have here? So let's imagine that the bond breaks right there. And we'll have CH3. Oh my bad, that looks like any CH3, one carbon there, and there we go. Right? There was equal sharing or equal division of electrons